There is a moment almost every parent knows. You hand your baby to someone, a relative, a friend, someone perfectly safe, and your baby loses it. They cry like they are in danger. They reach back for you like you are the only safe thing left on earth. And you wonder what is wrong. Maybe you think your baby is being difficult. Maybe you worry something is off. But here is the thing. Nothing is wrong. In fact, something is finally right. That cry is not a malfunction. It is a milestone. And what your baby just did with their brain in that moment is more sophisticated than you might ever imagine. To understand why your baby screams at a stranger, you first have to understand something about how they see you. Because this story does not begin with fear. It begins with recognition. From the moment your baby is born, their brain is doing something extraordinary. It is building a map of you. Not a simple picture, a full sensory portrait. Within hours of birth, your newborn already prefers your face over the face of a stranger. Researchers have shown that babies as young as 12 to 36 hours old will look longer at their mother than at an unfamiliar woman, even when no voice or scent is present. Just the shape of your face, the contrast of your hairline, the geometry of your features, that is enough. Your baby is already choosing you. But vision is only the beginning. Long before your baby can see you clearly, they already know you by sound. Your voice has been their constant companion since the third trimester. Muffled, low, traveling through fluid and tissue, but unmistakably yours. Studies have confirmed that newborns not only recognize their mother's voice from birth, they will actually work harder, sucking more vigorously on a pacifier, just to hear it over the voice of a stranger. Your baby does not just hear your voice. They prefer it. They seek it out. It calms something deep inside their nervous system. And then there is smell. This is the sense most people underestimate, but for a newborn, it may be the most powerful one of all. Within days of birth, your baby can distinguish your scent from the scent of another mother. Research from the University of Burgundy has revealed something even more remarkable. When 4-month-old babies are exposed to their mother's body odor while looking at faces, their brain's ability to process those faces is measurably enhanced. Your scent literally sharpens your baby's ability to see. The mother's smell acts as a kind of biological spotlight, helping the infant brain focus on the most important visual information in their world, which is faces. So before your baby ever cries at a stranger, something astonishing has already happened. Their brain has spent months constructing a rich, layered, multisensory identity of you. You are not just a face. You are a specific combination of voice, scent, warmth, rhythm, and touch that no one else on earth replicates. Your baby has built a neurological home inside their mind, and you are it. Now here is where the story turns. Because this map your baby has built, this detailed internal portrait of who belongs in their world, it does not just help them recognize you, it gives them something else entirely. It gives them the ability to recognize who you are not. Somewhere around 6 to 8 months, something shifts inside your baby's brain. It is not sudden. It has been building quietly, like a tide rising in the dark. But one day you notice it. The baby who used to smile at everyone now stiffens when an unfamiliar face appears. The baby who could be passed around a dinner table without complaint now clings to you like the world outside your arms is hostile territory. Most parents interpret this as regression, as if their baby has lost something. But the opposite is true. Your baby has gained something enormous. To understand what happened, you need to know about a cognitive milestone that is unfolding at almost exactly the same time. It is called object permanence. Before this point, when something disappeared from your baby's sight, it essentially ceased to exist for them. Out of view, out of mind. But around 6 to 8 months, your baby's brain makes a leap. They begin to understand that things continue to exist, even when they cannot see them. When you leave the room, you are no longer gone. You are somewhere. This is a revolution in how the infant mind models reality. And here is the connection most people miss. The same cognitive machinery that allows your baby to understand that you still exist when you are not visible is the same machinery that allows them to evaluate a stranger as someone who does not fit. Your baby has been building mental categories, what psychologists call schemas, for the faces and voices and smells that populate their daily world. These schemas are not just memories, they are expectations. Your baby now has an internal template for what a safe person looks and sounds and feels like. And when someone walks into the room who does not match that template, the baby's brain does not simply register a new face, it registers a violation, a gap between what is expected and what is present. That gap is what you see when your baby starts to cry. This is not irrationality. This is pattern recognition operating at an extraordinary level. Your baby's brain is running a comparison that involves the fusiform gyrus, a region in the temporal lobe that specializes in face processing. In adults, this area lights up with greater intensity when viewing a familiar face versus an unfamiliar one. In infants, this same region is undergoing rapid development during the exact months when stranger anxiety appears. The timing is not coincidental. The brain is building the hardware for social discrimination, and your baby is using it for the first time. But your baby is not just comparing faces. They are reading the entire room. Developmental psychologists have documented a behavior called social referencing. When your baby encounters something unfamiliar, whether it is a strange object, a new environment, or an unknown person, they do not just react. They check. They look at you. They search your face for information. Are you smiling? Are you tense? Do you seem comfortable with this person? A landmark experiment by Joseph Campos using what is known as the visual cliff demonstrated this beautifully. Babies were placed on a glass surface with an apparent drop-off beneath them. When they reached the edge and looked uncertain, they turned to their mothers. If the mother smiled and encouraged them, the babies crossed. If the mother showed fear, the babies refused. Your facial expression was the deciding variable. The same principle operates with strangers. Research led by Duhosne at the University of Reading showed that when mothers were trained to interact with a stranger in a socially anxious manner, their babies became significantly more fearful and avoidant of that stranger afterward. The mothers made no direct gestures to their babies about the stranger. They simply behaved nervously, and the babies absorbed it. They read the room through their mother's body and adjusted their response accordingly. So when your baby sees a stranger and then looks at your face, they are not just being clingy. They are gathering intelligence. They are asking you, without words, whether this new person is safe. And your answer, written in the micro-expressions of your face and the tension in your body, will shape what they do next. Think about what this means. Your baby is not blindly afraid. They are conducting a real-time, multimodal threat assessment that integrates facial recognition, memory, emotional reading, and social information, all within seconds, all before they have learned a single word. That cry you find embarrassing at a family dinner is the sound of a brain doing exactly what evolution designed it to do. And this is where the story goes deeper than most people expect. Because that cry your baby makes when a stranger approaches is not just a sign of cognitive development. It is a signal from one of the oldest survival systems in the human brain. The amygdala, a small almond-shaped structure buried deep in the temporal lobe, is the brain's threat detection center. It processes novelty, evaluates potential danger, and triggers the cascade of emotions we experience as fear. In adults, the amygdala activates when we encounter unfamiliar faces. But in infants, this system operates under different rules. For the first few months of life, your baby's amygdala is essentially held in check. Stress hormones that would normally activate fear responses are suppressed during what scientists call the stress hyporesponsive period. This is not an accident. It is by design. A newborn who screamed at every unfamiliar face would be at a disadvantage. They need to bond. They need to accept caregiving from whoever is providing it. So the brain temporarily dials down the fear system, creating a window of openness, a window for attachment to take root. But once that attachment is established, once your baby has built their internal map of who is safe, the rules change. The stress system gradually comes online. The amygdala begins to respond to novelty with increasing vigilance, and stranger anxiety emerges, not as a flaw in the system, but as the system finally working at full capacity. Jerome Kagan, one of the most influential developmental psychologists in history, spent decades studying how early temperament predicts later brain function. His research revealed something extraordinary. Infants who were classified as highly reactive at 4 months old, meaning they showed intense motor activity and crying when exposed to unfamiliar stimuli, grew up to have measurably greater amygdala reactivity to novel faces almost 20 years later. A behavioral signature visible in a 4-month-old baby predicted the way their brain would respond to strangers in adulthood. That is how deeply wired this system is. It is not a phase your baby will simply outgrow. It is the foundation of how their brain will evaluate the social world for the rest of their life. Now think about the timing of all this. Stranger anxiety typically peaks between 8 and 18 months. This is precisely the period when most babies begin to crawl and then walk. For the first time in their lives, they can move away from you. They can explore spaces you are not in. They can encounter people and objects without you beside them. From an evolutionary perspective, this is one of the most dangerous transitions in a young human's life. A mobile infant who approaches everyone without hesitation is an infant at risk. So the brain activates a counterbalance. Just as your baby gains the ability to move toward the world, their brain installs a filter that makes them cautious about what they move toward. Stranger anxiety is that filter. It is the brain's way of saying, you can explore now, but not everything out there is safe. So check before you trust. This is why your baby reaches back for you. Not because they are weak, because they are smart. You are their reference point, their compass, their biological definition of safety. Every time they look at your face in the presence of a stranger, they are using you as a tool to navigate uncertainty. And every time you respond with calm, with warmth, with steady reassurance, you are teaching their brain something it will carry forever. You are teaching it that the world is manageable, that fear is not the end of the story, that there is someone who will help them make sense of what they do not yet understand. And there is something else worth knowing. The way you respond to your baby during these moments does not just comfort them in the present. It shapes the architecture of how they will handle uncertainty for years to come. When you hold them through that fear, without dismissing it, without forcing them into the stranger's arms to be polite, you are reinforcing a neural message. You are telling their brain that its alarm system is heard, that its signals matter, that safety is not about the absence of fear, but about having someone who stays steady when fear arrives. Research on attachment has consistently shown that infants whose caregivers respond sensitively to their distress develop more secure attachment patterns, and those patterns predict better emotional regulation, stronger social skills, and greater resilience well into childhood and beyond. So the next time your baby screams in the arms of a well-meaning relative, do not apologize. Do not rush to explain it away. Take a breath and recognize what is actually happening. Your baby's brain has spent months building a portrait of you, so detailed that it spans every sense they have. They have constructed categories of safe and unsafe. They have developed the cognitive architecture to hold you in their mind even when you are not in sight. They have learned to read your face for emotional information. And they have activated an ancient alarm system that exists for one purpose only, to keep them close to the person they trust most in the world. That cry is not a problem. It is proof. Proof that your baby's brain is developing exactly as it should. Proof that the bond between you is not just emotional, but neurological, etched into the very circuits that process faces and voices and scent. Proof that in a world of 8 billion faces, your baby's brain has already answered the most important question a young mind can ask. Who is mine? And the answer, the one their entire brain is organized around, is you. If your baby is going through this right now, tell us in the comments what their reaction looks like. Do they freeze first and then cry? Do they immediately reach for you? Do they look back and forth between you and the stranger before deciding? Every baby does it differently, and your story might help another parent realize that what they are seeing is not a problem to solve, but a milestone to celebrate. And if you have ever wondered what happens inside your baby's brain while they sleep, why they twitch, why they sometimes smile with their eyes closed, why their sleep is so fragile and yet so fiercely protected by biology. That is exactly what we are exploring next, because what their brain does in the dark may be even more extraordinary than what it does in the light.